Let's now do the second example from that page. Following the same steps. Step 1, isolate the radical term. And remember, if I have something with a 1/2 power, that is the same as a root. So in this case, the radical term is x plus 1 to the 1/2 power. So if I look at it, I have a plus 5 next to it, so we are going to subtract 5 on both sides. So isolate the radical term by subtracting 5 on both sides. So this is going to go away, and on the left we have x minus 5, and on the right side we have that radical term isolated. Step 2, square both sides of the equation. So just like what the 2 and the square root does, the 2 and the 1/2 power also undo each other, so that we only have x plus 1 on this side. This is x minus 5 being squared. Now, before I can move on to step 3, it might help to simplify this a bit more. I want to remember that if I have x minus 5 squared, that's the same thing as x minus 5 times x minus 5. So I need to multiply all of this out before I can really move forward. So first, outer, inner, and last. So on the left, I'm going to have x squared minus 10x plus 25, and then equaling this right side here. Step 3, solve for the unknown by moving terms so that the equation equals 0. Because what we have here is we have a quadratic. So in order to solve for x now, we need to set it equal to 0. So I'm going to subtract x on both sides and subtract 1 on both sides so that we get 0. And then over here, we're going to have x squared minus 11x plus 24, and then we need to factor it. So I'm going to go ahead and factor by doing guess and check. That's going to give me x. So I have to think about what multiplies to 24 and adds up to negative 11. So for 24, what there is 4 and 6. But if they're both negative, it'll give me 10, 8, and 3. So that works. So it's going to be negative 8 and negative 3. So I have x minus 8 and x minus 3 as factors, and from that factored form, I have x equals 8, and from this factor, I'm going to have x equals 3. So we're not fully done yet, because we don't know for sure that those are our solutions. We have to check for extraneous solutions. So remember, step 4 is to check for extraneous solutions. So what that means is those two solutions we got, we need to substitute it back in and see if it gives us a true statement. So let's start with 8. So plugging it in place of everywhere where we have x, it's going to be 8 equals 8 plus 1 to the 1/2 plus 5. And then just like before, we're going to follow the steps by doing order of operations. So I'm going to start on this side and look inside my parentheses, and 8 plus 1 is going to give me 9. So we have 8 equals 9 to the 1/2 plus 5. A 1/2 power is the same as a square root, so we're going to have 8 equals, the square root of 9 is 3, and then plus 5. 8 is equal to 3 plus 5, 8. This is true. So the thing I checked was x equals 8, so x equals 8 is indeed a solution. We do still need to check the other one. We do have to check both. So now let's go ahead and check the other solution, which was x equals 3. So that's going to be 3 equals 3 plus 1 to the 1/2 plus 5. And then again, we are following order of operations. 3 is equal to 3 plus 1 is 4. And then we're going to do the 1/2 power, which is the same as a square root. 3 is equal to, square root of 4 is 2. 3 equals 2 plus 5, 7, that's a false. So that means this value, x equals 3, is extraneous. And when I specify my final answer, I do want to make sure I'm including both. I have x equals 8, which is my actual solution, and x equals 3, which I need to specify and label as my extraneous solution.